All right, this time we're in Chapter 8, Section 5, number 11. Again, we're looking at hypothesis testing. 5 years ago, 3.9% of children in a certain region. So this is probably, since this is in the past, I'm going to assume this at this point, we'll find out here in just a minute, that I was going to say the mean, or this is not the mean, this is a proportion. So the proportion of it's 3.9%. Several years ago, sociologist wishes to test whether the current proportion is different. Perform the relevant test at a 5% level of significance. So alpha equals 0.05. Level of significance. To see whether the test proportion is different. Perform the test. I guess I just said that, different at the 5%. So we have a random to see with this data from a random sample. So the data for this sample is going to be 2,759 children, and 119 live smaller than a parent. So the ratio out of that 2,759, 119 are the other. So our sample here, the sample proportion, is going to be 119 divided by 2,759, or 0.043, or 4.3% if we want to look at it that way. So I'll put this one back up here to 0.039 as well, so we get that in decimal version. All right, let's look next here. So we have to go back to our 5-step process for doing hypothesis testing. First thing we always look at in hypothesis testing is what is the null hypothesis. So in this case, our null hypothesis is that the proportion of the actual sample of the actual population is going to be different from the proportion of our sample. No. Sorry. The null hypothesis is that they're the same. So our null hypothesis is they're the same. The alternative is that they're different. The alternative is that something has changed from the 5 years ago when the information was determined that 3.9% of the children, or the 0.039 proportion, those children live with someone other than a parent. Our new data that we just got in the sample was that it's 0.043. So we'll see at a 5% level of significance if those numbers are different. All right, so second then is determining the test statistic. And in this case, we're looking at proportions. We look in the proportion section, and we have the Z being our test statistic for, as we usually are doing, but the sample proportion minus the null hypothesis proportion divided by the square root of the null proportion times the 1 minus the null proportion, or Q null, over the square root of that whole thing over N. Make that looking more square rootish. Right, so our sample proportion here is 0.043 minus our null proportion, or original proportion, divided by the square root of 0.039, and 1 minus that, or 0.961 divided by 2,759. So this equals, let's see, 0.004 divided by the square root of 0.123, zeros in there, if my count is correct, 135, which goes on down to equal 0.004 over 0.00367, equaling 1.09. Okay, well, I guess that's 2 and 3. I always end up doing those together, because 2 is determine the test statistic, and then 3 is putting the data in for it. And as soon as I have the test statistic, I just dive in and put the data in. So I do 2 and 3 at the same time. All right, so 4 now is looking at the reject window. So, so the reject region, I guess is another way to put that. And since we're looking at different here, this is a two-tailed test. So we're looking at having the percentage here being our 0 and our z value, the 0.025% on either side here. So looking at what value of z is here, so then we can look to see what all is in that range in terms of that's our reject region. Now this should look very similar here. So this is going to be z of 0.025. So this will be a minus, this will be a plus z at 0.025. We recently did that at least in my recent, because I'm doing several of these problems in a row. So when I had done that before, I looked up the z for 0.025 using the t-distribution table with the degrees of freedom at infinite. So that being where the t-distribution equals the z-distribution, the standard normal. And at that point, the z at 0.025 is 1.96. So our values here are minus infinity, or our regions up to minus 1.96. Can draw it that way. And then from positive 1.96 all the way up to positive infinity. So that's looking at those two regions there. And so number 5, then we're going to compare our value back up here, calculated in 3, to that region. And 1.09, let's continue drawing that one, is inside that region, so it is not in the reject regions. So we do not reject the null hypothesis. So we do not have enough information. So let's word it that way. So data does not support a difference in current sample being different from the 5-year-old sample at 5% level of confidence. So we're not rejecting the null hypothesis this time. Okay.